Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 60 in chapter 9. Chapter 9 is about the linear momentums. For this one, we have two particles, A and B, have the elastic collisions, right? And then after the collisions, we find that A moves with the VA plus, make an angle theta A plus with X component, and B moves at the direction VB plus, make an angle theta B plus with X direction. So because this is the elastic collisions, first thing the momentum is conserved. So we look at the momentum at X component. So initially we have MAVA equal to final momentum at the X component, right? So this one we can project the VA plus in X component. So this one is VA plus theta A plus cosine theta A plus, and B is VB plus times the cosine theta B plus, right? So this is both VA plus and VB plus can be projected in X component. So this one we get this equation. And then look at the Y component. Initially it's 0. And after the collision, we can find it has two components. First one, this one is VA plus times the sine theta A plus. And this one is VB plus sine theta B plus. They had the opposite direction, so this is minus sign. The next one is kinetic energy is conserved. After we solve these three equations, we get a very beautiful equation. Look at this one. There, this is theta A plus is called scattering angle, and this is cosine theta A plus is just the cosine of scatter angle equal to this function. First one we need to prove it can take any angles, any values between 0 to 180 degrees if this MA is smaller than MB. So how can we do that? First one, we consider this equation, right? We write this equation there, and we know MA is smaller than MB. And most obviously, we can see initially we have VA, and after the collision we have VA plus and VB plus, right? So that means VA must large or equal than VA plus because energy is conserved. Do you agree? So energy cannot generate by itself. So the total energy is 1/2 MAVA squared. So after that, so this VA plus cannot larger than this one. Agree? Yes. And then if the A is smaller than B, so it means the B divided by A, this ratio is larger than 1, right? So this term is larger than 2. This term is smaller than 0. Agree? And the most limited situation is VA plus just equal to VA. So VA plus just equal to VA in the cosine. So cosine theta A plus equal to 1, right? Can equal to 1. So this one, so if this one VA equal to VA plus, so this term is 1. This term is 1. So this term is 1. This term is 1. And then cosine theta, you can see this if this is 1, this is 1. We solve this equation, we can find cosine theta A plus equal to 1. If cosine theta A plus equal to 1, look at there. Theta A is just 0. Agree? And another thing, we know this A plus couldn't larger than A, so VA plus will just decrease. When it decreases, we find this term dominant, right? This term dominant because it will become larger and larger. This term will become smaller and smaller. So this term will dominate, and this term is smaller than 0. So that means the cosine theta A plus was smaller than 0. And we don't know how much it can slower. So this term can be as slower. So at some point, it can equal to -1. Do you agree? Because we just can prove it is smaller than 0. So at some point, it is smaller than 1. When it equals to at some point it can equal to -1. It can just smaller than 0, and the limited situation is equal to -1. So for cosine theta A plus equal to -1 is just pi 180 degrees. We proved it. The next one is that we need to prove it has a maximum angle. So still we look at this equation, and this one we is known and everything is same, but except A is larger than B. So A is larger than B. This term is smaller than 1. So this term is smaller than 2, and this term is larger than 0. So we find the cosine theta A plus is larger than 0, right? Then another situation is when the A plus just equal to A, we find the angle theta can be 0. Now how can you find the maximum? For the theta A plus, for maximum, we know it is larger than 0, so we can do the derivation, right? We do derivation with VA plus. And then when we do this derivation, we can find the phi. Cosine phi equal to this equation. Then we are done. Thank you.